42% of the global carbon emissions comes from the AAC industry, 15% from embodied carbon in our buildings. That's the upfront carbon investment we take by building our cities in stone, concrete, steel or wood, and 27% from the operational carbon cost of keeping our cities running. Hi, my name is Jesper and I'm an architect in Autodesk. In this video, I'll break down one tiny piece of the puzzle towards designing more sustainable cities by introducing you to the embodied carbon analysis for Autodesk Forma. I'll show you how we, as architects, can use this tool to start meaningful discussions backed by data with all our stakeholders around what kind of carbon footprint we put into our buildings at a stage of planning where we can have a substantial and meaningful impact. We are going to go through a project, make some design assumptions on our building massing, which results in an apples-to-apples comparison of decisions which will impact our embodied carbon footprint downstream once we get into building design and construction. And I know calculating embodied carbon is a sort of a new ask for a lot of us designers out there, unless you've specialized in sustainability, but we can't leave sustainability to the experts. We all need to pitch in. So here is what I'm asking you all to do.
The embodied carbon analysis in Forma now shows up in the right side menu in the new project, ready to use. Running the embodied carbon is done by adding the necessary properties and clicking the Run Analysis button in blue. You can now stack basic buildings on top of each other, and the analysis will take the relationship between adjoining buildings and stacked buildings into account when making an assumption of what kind of structural loads this building will need, what kind of facades they have, and will adjust the required structure assumed automatically. This allows you to define two different structural systems if that makes sense for your project. In this example, I'll give the building on top a residential function and an aluminium range screen envelope with about 50% window to wall coverage, and then a mass timber structure. The podium building I'll define as a commercial space and give it a hybrid concrete steel structure. You can also select multiple elements and define properties all at once. Now, with these assumptions in place, we'll run the analysis and you'll see that this building we just designed lands at a hefty 4,010 tons of embodied carbon, given our geometry and assumptions we defined in our properties. Let's play around with this. You can tell that the structure is definitively the most impactful part of this equation, so let's see what happens if you redefine this podium as mass timber as well. By making this simple change, we've reduced our embodied carbon footprint from 2,610 tons down to 790 tons, so only 30% of our initial impact on structure alone. That is a significant insight. If we opt to make the podium structure reinforced concrete instead and try to remedy this impact by reducing our window to wall ratio, let's see how that would impact our design. So structurally, we've spent 1,070 tons of carbon. It's higher than mass timber, but still down about half of our original assumption. Doing this experiment gives you directional advice on what to consider when considering embodied carbon in your project in the pre-design phase. By experimenting, we now know that there's a lot of carbon to save by considering either reinforced concrete for a podium over hybrid steel, and even more so if we try for a full mass timber structure instead.
And that's an effort worth making and a design shift worth continuing to explore. Because at this point, that's all it takes to start off the conversation you will continuously have with everyone involved in your project.